We're in the middle of the lecture on the probabilistic model, and last time we left after deriving this result. So remember, we started with the probability ranking principle. We said that the best possible way to rank your documents, the way that will give you the highest precision and recall and average precision and whatever you want, is to rank by the posterior probability of relevance, and really kind of obvious in retrospect. And by making several assumptions, the assumption of document representation, independence, a couple of other things, we came up with this form. So that posterior is rank equivalent under those assumptions to the product over all the words in the documents of this ratio, PW over QW, 1 minus QW over 1 minus PW, where PW is the probability that the word W occurs in a randomly picked relevant document, and QW is the same probability for the non-relevant document. So PW is sort of the word occurs given the positive class, and QW is same thing for the negative class. Now the question naturally is, this is nice and compact, and we could start estimating things at this point. And if we had examples, if we had relevance judgments, at least partial, that gave us some idea of what relevant documents are like and what non-relevant documents are like, then we can estimate everything here. So let's say that somebody comes along and gives us N1 relevant documents and N0 non-relevant documents. So these are our examples of class 1 and class 0, relevant and non-relevant class. So now we can just estimate those probabilities directly, and you have to remember what model you're operating on, right? The assumption that we made is that a document is a collection of Bernoulli random variables, right? 0, 1. PW represents the probability that a word is present in a randomly picked document. So the maximum likelihood for that is you take your collection of N1 relevant documents, you count how many of them contain at least one occurrence of the word W, and you divide by N1, right? You don't count multiple repetitions of the word in a relevant document. So it's just a percentage of documents that contain the word. You do N1W, that's how many documents, how many relevant documents contain W divided by N1. And what I'm doing here is I'm adding 0.5 at the top and 1 at the bottom, just to avoid zeros, right? And in case some word didn't occur in any of your relevant examples, you don't want to give it the probability of 0. Why? Why do you never ever allow probabilities to be 0? What's going to happen with a product if any one of these is 0, right? The whole product is going to turn out to be 0, so you never ever want PW to be 0 for anything, and you never ever want QW to be 0 for anything. Likewise, you never ever want 1 minus PW to be 0. That's why you add 0.5 at the top and 1 at the bottom. If some word happened to occur in all the relevant documents that you had, then N1W would be the same as N1, and if I added the same component at the top and at the bottom, I'd get 1 for PW, and then 1 minus PW would be 0. And that's a bad thing, because that 1 minus PW then in the product is going to obliterate my whole score. So these constants keep PW away from 0 and from 1. It's a crude form of smoothing. And I do the same for QW. The only difference is now I count how many non-relevant documents contain W. So that's nice and great, and if you have examples of relevant documents, then you can estimate those probabilities, and you can compute estimates of the probability of relevance for the documents. And of course the interesting question is, well, remember, why are we doing it? We're building a search engine, so in a search engine you don't actually get examples of relevant and non-relevant documents unless you really pinned your user down and forced them to do something that they don't want, which is to provide relevance judgments for you. But most of the time you're not going to have those. So the question is, what do you do if you don't have that relevance information? And the answer is, things get really messy, and we're going to look at, we're going to have to make further assumptions to reformulate that formula into something else that we can estimate with no examples. But